Hey, Professor Bob Young back at you. And in this instructional video, we're going to look at logarithmic functions. So the definition of a logarithmic function is y equals log base a of x, where a must be a number greater than 0 and not equal to 1, and x must be greater than 0. So this function defines the logarithmic function with base a that we talked about some in the last lesson when we talked about converting from logarithmic form to exponential form and so forth. So let's take a look at how they tie in. Exponential and logarithmic functions are inverses of each other. So the graph of y equals 2 to the x that we looked at in earlier sections is in red there. And the graph of its inverse is found by reflecting the graph across the line y equals x. So remember, we also have talked about inverses and so forth. And remember, for every xy on the red line, it becomes yx on the blue line. The domain becomes the range becomes the domain. And they are inverses because they are both 1 to 1. So the graph of the inverse function defined by y equals log base 2 of x, shown in blue, has the y-axis as a vertical asymptote. So remember when we were graphing exponential functions, we had a horizontal asymptote, which we had the ha. Ladies and gentlemen, in blue here, these logarithmic graphs, since they must be greater than 0, the domain here, the va, is back for this one. The vertical asymptote here is x equals 0. So that graph will never touch or cross the vertical asymptote, or va. So here we go. Since the domain of an exponential function is the set of all real numbers, and the range of a logarithmic function also will be the set of all real numbers, so we knew that. In the same way, both the range of an exponential function and the domain of a logarithmic function are the set of all positive real numbers. So logarithms can be found for positive numbers only. Now let's think about this for a second here. And then I already told you that we could use our calculators in the last video to calculate, let's say, the log of 100. Now, if they don't put a base number there, you should know from this point on that it means base 10 on a common log. So what you're asking your calculator, if you put in the log of 100, you're saying, calculator, 10 raised to what power is 100? And of course, your calculator will give you 2. But look at this rule down here. Since the domain must be positive numbers here, I tell you what, I dare you to ask your calculator this one. Calculator, what is the log of some negative number? Let's say of -7. Like that. And you know what you're asking your calculator? You're saying, hey, calculator, 10 raised to what power gives me a -7? And your calculator's like, it doesn't know, it can't answer it. And it's probably spitting out error or cannot do or telling you where to go or something there, and you say, hey, calculator, watch it. Because if you think about this, if you put 0 in for the question mark, something to the 0 powers 1. If you start putting positive powers in there for the question mark, you get 10, 100, 1,000. And even if you put a negative power in there for the question mark, you start getting 1/10, 1/100th, 1/1000th. Will you ever get a negative here? I don't think so. So we're going to put So that is why, one reason the logs must be positive. And we're going to look at some others too. Oh boy, it's graphing time. So we are going to go ahead and graph this function y equals log base 2 of x. All right. Now what I want to do, and this is how most textbooks will show you here, and they'll go through the rigmarole, but what Young wants to do is go ahead and change this to exponential form, and you know what's coming, the clown face. Do you see it smiling at you? You can even use the clown face to graph logarithms. Yes, indeed, ladies and gentlemen. So 2 raised to the y power equals x. So remember, that 2 on a logarithm is the base number. And then if you want to make a table of values, you notice they have one over here. I'm going to make my own table of values here. So I'm going to interject a little bit of something here and see if it makes sense to you. I hope so. And I'm just going to say, all right, let's do it this way with this equation. So I'm going to put values for y in to get x. So if I put 0 in for y, 2 to the 0 powers 1. 1 in for y gives me 2. So you're starting to see these values here show up. 3 will give me 3 for y will give me 2 cubed of 8 there. So here is this one. Now, let's show you something else here. What if I put negative 1 in for y? Well, remember, that would be 2 to the negative first power. So x would be 1/2. So that's where they're getting these numbers here in the chart. If I put negative 2 in for y, I get 2 to the negative 2 power would be 1/4 and so on. So notice this graph for the logarithm, and they've got it plotted over here. And notice it says it's increasing and continuous for its entire domain, and the domain of this creature is 0 to infinity. So notice the x values, the asymptote here, the va, and let me go ahead and put that back in green, is here. It will never cross or touch. So this is the basic logarithmic graph for when a is greater than 1 here. And of course, in this example, a was 2. All right. Now, you notice one thing it doesn't say, hey, what's the range? Young, what's the range of this graph? Now, on y, it can go where? From negative infinity, it's heading that direction on y, angling toward positive infinity. So the range of the logarithm, all real numbers. All right, so notice it says here that the y-axis is the va as x approaches 0 from the right. And we've talked about that. And notice they also put the range and domain on the graph here. So they also gave us a few pointers down here. The graph passes through the points 1 over a. Now, the one we did, it was 1/2. All right, so a was 2. So it will pass through 1/2, -1, 1, 0, and 2, 1 in this case. So I don't know if a lot of students would always see that or not either, but they throw that in there. Now, notice when that a number is a fraction, all right, the log kind of flips the other way like the exponential function did, all right? So when the a number is 1/2 here, and they're plotting that point, and here's how they do it again. They don't show this very well, so I'm going to go ahead and spell it out here. They did the clown face and said 1/2 raised to the y power equals x, and to get their values. All right, so if they put 2 in for y, x is 1/4. If they put 1 in for y, x is 1/2. So they just changed from logarithmic to exponential form to do this. Now notice here, if you say 1/2 to the negative first power, it's that reciprocal rule. It makes it 2 to the first, and you get your point there. 1/2 raised to the negative second power gives you 2 squared, or 4. So here is how this graph behaves, as you can see to the right here. It decreases, and you certainly don't want an investment like that, but it is continuous from 0 to infinity on x. And again, notice the range is negative infinity to infinity. The va is x equals 0. And it passes through the point 1 over a, and it does that stuff there too. So we'll just kind of fast forward here. So then they give us some characteristics of any logarithmic graph. So it does the point thing there. I think the big thing is that usually it'll pass always in that form through this point 1, 0. And we said if a is greater than 1, that base number, it tends to look like this through 1, 0. So that would be the point 1, 0. And if a is a fraction, it'll do this type of thing through 1, 0. But it'll go through 1, 0. It'll decrease like we've been looking at there. And of course, they talk about the domain and the range. So we'll carry on here. Now it says graph this function y equals log base 1/2 of x. And I think we've already gone through this argument here. So we're going to look at this. Now again, I would say y equals log base 1/2 of x and do the clown face. So 1/2 to the y power equals x. And notice here they show the exponential graph too, where x and y are interchanged. So that is where we came from with exponential functions. So I'll put exp here, and here is its inverse, the log function. All right, they want us to graph another one here, y equals log base 3 of x. So they went ahead and they actually clown faced this one for us. They changed this to y, and then they're getting smart. X equals 3 to the y power. And they went ahead and plotted some points. So you can see that this graph is going to look like the majority. I think I would have liked to extend this thing down a little bit more. I mean, I might have brought it closer and closer this way if I was graphing it. And I might have shown the va a little better. See, the domain, x must be greater than 0 here. Because remember, if you try to put a negative number or 0 in there, even if you did that on your calculator, if you were going base 10, if you asked your calculator what the log of 0 is, it would go, error. See, because it's always got to be a positive number there. Not even 0 will work. So it says, if you write a logarithmic function in exponential form, choosing y values to calculate x values, be careful to write the values in the ordered pairs in the correct order. You might have caught me. I almost did a x instead of a y on one of them, and I had to catch myself and be careful there because you're really substituting in y's to get x when you do that. So more examples. You know Young likes to give you a lot of them. We're going to go ahead and take this one, y equals log base 2 of x minus 1. And if you remember your translating here, we might expect this one with the minus 1 inside the parentheses to shift 1 to the right. And that's exactly what it's going to do. So the va, or the vertical asymptote here, will be x equals 1. So your shifting is on. It could vertically shift, horizontally shift. The domain of the function now becomes 1 to infinity, since logs can be found for only positive numbers. So to find some ordered pairs to plot, let's use this equation down here on the bottom. And I bet you, hopefully, they're going to clown face it as we go on. So let's see here in the next graphic. Aha, here it comes. So 2 raised to the y power equals x minus 1. And then notice they added 1 here just to make it easier to get ordered pairs. Because if you don't, it's going to be hard. So here is the graph. Now, what I don't like here, and I'm going to go back real quick, they didn't show how to plot the points for this thing. So x equals 2 to the y power plus 1 here. Let's write that in here. And let's get some points real quick, because I like to have a lot of points when I graph these creatures, and show you what I mean here. So if we put 0 in for y, being careful here, 2 to the 0 power plus 1, 2 to the 0 is 1 plus 1, we get 2 for x. See, so there is that shift of 1 unit. It usually goes through 1, 0. Here it shifted 2, 0. If we put in 1 for y, we get 2 to the first power plus 1 will give us x, so we'll get 3. So notice 3, 1 here. We could put in 2 for y, get 5. And you can see closer how this graph behaves. Now, I would also like to put in, let's say, a negative 1 for y. what is 2 to the negative first power plus 1? Well, remember that 2 to the negative first power is really the fraction 1/2. If you bring the 2 to the first to the denominator, so we get 1 and 1/2, which would be about, on my graphing tablet here, it gets tough here, and you can see as y becomes smaller and smaller and smaller, we're going to get closer and closer and closer to the va, but never touch or cross it. So your shifting is on here, ladies and gentlemen. Now here's 1 log base 3 of x minus 1. Now with that minus 1 on the rear, I would expect this thing to do a vertical shift 1 unit down, as we will see here. So changing this to exponential form, we're going to have, and we're doing the clown face again, they went ahead on this one and added 1 first to get the log by itself, and then they clown faced it to get x equals 3 to the y plus 1 power. So let's write that again. X equals 3 to the y plus 1 power. Now again, I don't see a table of values here, and I don't like it when they don't do table of values, so I'm going to do some points here with you. Put 0 in for y. I'm going to get 3 to the 0 plus 1 power. What x will be 3 to the first, or 3. Check this out. I could put negative 1 in for y. That would give me 3 to the 0 power, or 1. See, so this one here, it went through 3, 0. Here is 1, negative 1. And of course, you could put more points in and so forth as well. So this one shifted down 1 unit, but notice, did it affect the va? No, because on this one, it's still going to be all positive numbers, while the range will be negative infinity to infinity. So I like some of these graphs and graphics. I hope you're getting something out of it here. Remember, logs are just exponents in disguise, and this handout in your care package summarizes a lot of things. And we've even got base E on here we'll get to later on. So Bob Young signing off. Until the next video, hit that homework and do well. Take care. Bye-bye.